I guess in context here, probably, where for me, this discussion is going is, okay, what was the problem we were trying to solve? Everybody try to get that around. And it's not the same for every group in government. It's not the same even within the military and DoD. There are disciplines where the problem is fundamentally different than the one that you're trying to articulate for the warfighter at the edge. And today is about the warfighter at the edge. And for me, the history on that and the problem that we're trying to solve is, it's really painful, but in Vietnam, that's my age, we were losing people, and we were losing systems, airplanes, because what we had fielded as a military and the problem we actually had to solve on the battle space were two different things. We relied on the troops to try to adapt whatever they had in the way of tools to be successful, okay? And the speed of agility of the troops to do that was somewhat limited by we couldn't give them new tools, and we couldn't retrain the entire force in the course of a multi-year conflict in Vietnam. And you can go to any conflict, whether it be before Vietnam or after Vietnam. The scale may change, but the problem does not. Okay? And so I guess the most striking example out of Vietnam was that we were losing airplanes at too high a rate. And we figured out why pretty quickly. And then after the war, we fielded the F-16, 18, 22, 15, all of those great airplanes to fix that problem that we had with the platform, okay? And from the training standpoint came the top guns of all of the services and all of the disciplines, okay? After the war was over, okay? So that kind of delay is problematic for us, number one. Number two, fast forward, if you think it's gotten better today, we did with the current conflicts, the Iraq-Afghanistan conflicts, IEDs, and the problems they caused. Instead of taking 15 years or something to develop a platform solution to that, we went about as fast as industry could go to do the MRAP activity, okay? The good news was that was faster. The bad news was it was still measured in years, okay? And we lost a lot of lives in those years. And so what we're trying to understand today is, with the tools of computational power, the ability to communicate, both in data and in form, can we train faster? Can we respond inside of operational timelines, tactical timelines? Can we come up with solutions that would at least reduce the risk on the battle space, if not give us tactical advantage, ideally? Those are the things that we're looking for. These are my words, okay? How to get there is not a problem of innovation, okay? We've got the best innovators in the world. Our small business side, our academic side, et cetera, it's the best in the world. Our problem is adoption, okay? How do we pick a winner? How do we then look at it, scale it quickly? And then how do we get it out to a 2+ million man force in training so that they can use those tools when they get them instantly? How do we start to think about doing that? We're organized by domain. Okay, so I've got a good ground army, I've got a good air force, I've got a good sea navy, I've got a good space, cyber, you pick it all, okay? Nobody's really organized jointly. Nobody's really organized cross-domain. Nobody's organized technically with our allies, okay? How do you start to bring the pieces together? The incentive structure is purely along domains. Okay? We can say all of the wonderful things we want about joint and all of those things, and we can do all sorts of revisions in the law, but the incentive structure is purely along the domain lines. There is no incentive for stepping out of them right now, okay? Other than just goodness of your heart, type things when it comes to budget time. And there's not a lot of heart when it comes to budget time, okay? So that's the challenge. The group that's around me up here, has a set of skills which really give you hope, okay, for me, for the old guy. Interdisciplinary approaches, not just a bunch of people who have been there and done that and have the t-shirt solving the problem, okay? Forward thinking, coming at it from different directions, understanding the opportunities that could potentially be presented. But interdisciplinary groups, we really, certainly in my time, had very little of that, okay? How do you get to scaling and get to scaling fast? I can't afford to train a 2 million man force to a whole new way of doing business or a new tool and sit down and do that in anything less than years, okay? Unless I have a way of fielding it and making it understandable for that high school graduate that it's instantaneous and intuitive to employ it in the battle space, okay? I just can't get there. So scaling is a big one. Sometimes with intent and sometimes by impact of the enemy, I have to act independently in the battle space. I'm cut off, okay? A lot of times, and actually quite frankly, most of the times, it's by design. I'd rather they not know I was there. I keep the element of surprise. But how do you do that in a world of cloud and comms that have to have a lot of energy and a lot of power to move globally? How do you start to think about that problem and how do you start to bring it to the battle space in a productive way? Resilience. I mean, I can't just have single path stuff, okay? I can't have one solution for everything. I need to be able to have, the term we're using today is future-proofing in my capabilities. I need to be able to react in probably one period of darkness. I can't do it that fast, my adversary is going to beat me. In any kind of competitive space, the winner is always working at the edge, okay? If I go to my counterpart I got Afghanistan on the brain, Ukraine, okay? I ask him, what are the top 3 things that you've discovered? Number 1 is always the value of the NCO, okay? Give him combat instructions, give him commander's guidance, and then give him the tools and let them go, okay? The other 2 were space and cyber that they just didn't have in the kit. But the NCO has, over the years, always been our competitive advantage, okay? But who makes the decisions about what we buy? It's rank, okay? And we've got to figure out how to work our way through that. And if we had the opportunity to collect the data at the edge, have analysts at the edge, that would change the game, okay? It would fundamentally change the game. Instead of who's the first guy to the chalkboard to map out what happened, I got data. I got real data here to tell me, okay? In the time between Afghanistan and, Vietnam and Iraq, we took the skill of the operational research analyst from the most important part of tooth and made it tail. And we got rid of most of the people that did operational analysis, analytics on the data, analytics on what was going on in the battle space. Sometimes it told a story that was not very flattering to us, and therefore it got squashed, okay? We've got to figure out how to bring that back. We can't do all of the things that we imagined to do without data, without good, hard data, okay? And that data is not going to be clean, it's going to be messy, and I wish you could say we could greenfield that, but it's a brownfield activity. I've got to go out and figure out how to take the systems I actually have and make them usable so that I can get data to understand what's actually happening in the battle space, and then respond to it with innovation, okay, to get back to the edge. Data and metrics, that is the fuel of the engine, and we've really got to pay attention to that. Okay, I'm going to start with a set of questions. You all think about what you want to ask about, and whether we touch on it, and we'll get to that as quickly as I can move through these questions. And so I'm going to start with Brandi. And it's just a relatively straightforward question, pretty straightforward and probably quick to answer is, how do you see Edge AI improving the Army and Army capabilities?
Thank you. First, thank you to you for your time. And I guess that little quick was you wanted me to be quick in my answer. So,
No.
No, but thank you also for DSI for this venue and the opportunity to speak to you as well. So Brandi Szczesny, representing DASA R&T today, the Research and Technology branch, really funding a lot of the Army, CIBR, and CIDR, and X-Tech programs, which bring innovation in AI right to our soldiers. So your question about Edge AI, and can I give you some specific examples? Yeah, sure thing. So I think within the Army, we tend to separate Edge and AI as two individual concepts, and then there's this really unique convergence where Edge AI exists. And the first things that come to mind are those autonomous systems. So GVSP, ground vehicle systems that are being utilized to bring edge capabilities to process data really close to where it's happening. That's absolutely like an explosion of where we've seen a lot of use cases lately. One specific example that comes to mind that's very easy to talk about is the SMET. It is used for supply chain. It's a small multi-purpose transport device that can reduce a soldier's payload. It can be used for logistics, for resupply, a very non-algorithmic warfare approach to AI, but a really enabling tool that we can use AI to help improve our soldiers' capabilities. And then the second one that I want to talk about where I see Edge AI is in a lot of wearables technology, particularly within DASA R&T. We've seen an explosion of devices and AI that can be used for analytics to report on soldiers' health and welfare. I think that's a critical piece of data that we haven't been able to harness before to give that commander the insights to his personnel and enable him to make key decisions right as the stress factors are happening and use that AI analytic to help guide some of that decision making.
Thank you. And Nomad, what are we doing to ensure resilience at the edge? Ensure that in a denied environment that we have the tools for the warfighter to be able to do their task.
Great, thanks a lot, General Cartwright. Sir, it's an honor to be on the stage with you today, and thank you for DSI for hosting this event. So though my uniform and my loyalty is to the Air Force, I'm actually serving currently up at the Office of Secretary of Defense at the Chief Digital and AI Office and responsible for joint experimentation across DoD when it comes to the fielding and accelerated fielding of AI and data-centric capabilities. And one of the things, sir, that really resonated based on what you said was the challenge of adoption. And that's one of the things that we see as the most difficult thing. Though the technology often is there, that adoption challenge gives us a lot of pause. And so the approach that CDAO has taken is to take an experimentation approach rather than a traditional requirements and waterfall development approach. And by getting early products out into the field, similar to I think what the Army is often doing as well, is we've found that when you put these capabilities, especially software, in the hands of the warfighter at the edge, and you sit them down next to a software engineer from one of the many vendors we work with, that the feedback loop is immensely tight, and it allows them to be able to look just to their left and say, oh, this is what's working, this is what's not working. It also allows them to your question about resilience, allows them to say, this is not working right now, I don't have connection to this. And so the engineers get to see that, they get to kind of tighten up that feedback loop. We just recently, in a GIDE event, the series of experiments that I run, we had out in the Indo-Pacific, we had an Army E5 sitting down next to the software engineers going through joint fires, kill chain work. And through the process of him sitting there, not only did he get to talk with the software engineer, identify gaps that were currently existed in it, but then he was able to develop up some of the TTPs that now were enabled by having access to this new software. To your point, sir, of sometimes there's a bit of a gap between the programmatic side, where the decisions are made, and then the actual edge warfighter. So experimentation for us is very much the approach that we're taking.
Awesome. And then, Eric, given the architecture of JADC2, how do we think about seamlessly integrating AI components at scale?
Sure. Thank you, sir, for the thoughtful question and introduction. JADC2 and AI inherently is a complicated space. When you think about what we have to put in place to require AI to work, unlike a legacy kind of siloed system, technologies have to be integrated in a couple different ways. We have technologies that are focused on AI training capabilities. That's cloud, that's GPU, that's infrastructure. We have technologies that are focused on inference or running AI models in JADC2. This is integration on OEM platforms, like the F-16, for example. And then between those two, we have technologies that have to connect where we train models, where we deploy models. These are sort of like the delivery systems, the machine learning operations space of AI. And the challenge with interoperability in JADC2 is we are only as strong as our weakest link across that spectrum. So when we think about an architecture for JADC2, if you look at successful projects, the further you go up, the more you find commonality. You can look at it as applications, data, models, pipelines, platforms, and infrastructure. And pipelines are the pieces of software that automates data and AI-intensive workloads and decision processes. Pipelines in our work with the government and the Department of Defense are really where we see opportunities for scalability, for rapidly integrating dual-use technologies, where we see standards like linchpins torque being implemented, standards for security like AI layer defense. This is really where the magic lives in the JADC2 space. One final point. One of the common things we see in these pipelines is something called an embedding model. These embedding models are what standardize data into features that can be analyzed by any company. And this is where from ISR missions, from PED missions, from you name your warfighting function in your mission space, this is really where, as a department, we need to prioritize standardization, prioritize compliance that allows for all of the great technologies to bring their best and latest innovations to the table.
I would like to just kind of brag on Booz Allen because I think there's an area here between the experiments that you run, which we do on a annual basis. We may run X number of them a year for hundreds of thousands of dollars to participate, et cetera, versus a new group that's kind of emerged, which are called these limited objective experiments, where you are hosted in to solve a problem. You bring whatever you have, and we iterate constantly, allowing small businesses and other entrepreneurs to have a chance to tweak and demonstrate value to then be considered for the larger experiments. We've been doing these in 3 or 4 different sites across the country. And one, you can get into these things very quickly, within a quarter. You can be into one of these and demonstrating and testing out and getting confidence, et cetera. And 2, you get instant feedback because we have the services integrated into these things to watch what's going on. And it's really amazing what has been accomplished in these. And Booz Allen and several others have been leaders in creating these opportunities before the major experiments to let entrepreneurs have time with both data and sensing, with targets that are real or effects that are real. Really, really valuable. So I really thumbs up to that work. And Seek, could you talk a little bit about ammo and a little bit about the benefits of Edge AI and linchpin and ammo both?
Yeah, Sik Chai, CTO, co-founder for Latent AI. So thank you, General Cartwright, for the introduction. Couple of things to point on with respect to ammo and linchpin, right? As you know, the edge is incredibly hard. It's heterogeneous, it's all over the place. There's no quite standard or anything, right? Building AI itself on the cloud is hard, right? And then you start to say, well, I need to build that for battery-powered device. It's kind of small. It has to be distributed. It's fundamentally different, so it is hard. So Latent AI's approach is say, we got to think about the workflow. We got to think about tooling such that you can bring the capability in a more consistent way. So you talk about the different properties about bringing capability, right? Resilience being one, being rapid would be one. I would say being robust so that it is consistent, And then part of that is repeatability. You can't just go and say, I got an AI model, but what I'm going to do for the next one, right? It got to be in that process. So within ammo and linchpin, both Navy and Army, they're looking at from that perspective, right? Part of the torque principle is about then that resiliency, that robustness, where if you have interchangeably pulling components, you can, right? The industry is moving very fast. AI today, if you think about a year ago, start thinking about LLMs today, it's all over the place. You can't flip a page in whatever news article and not hear about language models. The industry is moving very fast. The question is then, from a DoD perspective, how do you get there? Our perspective is on the tools and being kind of consistency in terms of how to develop that. And once you have not only the capability for the AI, but the tools to do it, then we free ourselves from that cycle, right, to deploy some of these AI.
I think to continue on that theme, Brandi, the idea of thinking about the energy required at the edge to do inference compute, to do a lot of the capabilities that we could bring to the edge with software, firmware type of capabilities. How do you start to think about the power side of this equation?
Yeah, it's certainly a consideration, right? It's not one of the factors that we can consider when you need to actually deploy and field AI, and yet do we have the power structure that can enable that as well? So there are multiple approaches to this. One is sustainable technologies, who can build the next generation of battery or solar power. Always something from DASA R&T we're looking at actively in our portfolios. And then the other piece is, how can you compress the model? How can you get it to be optimized as well? So are there techniques within the actual deployment of the AI algorithm that we could utilize so that we are using less resources or consuming less resources on the edge? Because in addition to just that AI algorithm on the edge, the soldier's also running a host of other apps and platforms, or apps and systems on their platform as well, that we have to be considered as well. So there's that trade-off balance. If we are enabling an AI technology, how do we ensure that we do that with respect to power consumption and also not detract from any other key capabilities?
I think that kind of leads us into, Eric, how do we start to think about adversarial attacks on the edge and AI?
Sure. Yeah. Thank you for the thoughtful question. This is a really important. I'm not sure I even call it an emerging threat space. It's here. There's operational risk, but also this is a space that really hinders adoption. If we can't demonstrate to the warfighter who is consuming this artificial intelligence or using a system that relies on it, we really take two steps back as a community. And so adversarial AI is incredibly important to the missions. I think to start, there are a number of frameworks out there that all of us can rally behind and contribute to. MITRE Atlas is one that we are very active with. The Army just published an RFI and is working on an AI layered defense framework, which has a lot of great underpinnings on system integration. And using those really across the entire AI lifecycle, whether it's looking for preventing data poisoning and data engineering workloads, doing federated data collection, model engineering. There's framework and actual neural network architecture selection that can keep you safer than others. There are adversarial hardening techniques that we can use to prevent evasion attacks. And then finally, on inference. There are hardware and software options that also can further protect models, keep them encrypted, make sure they are producing common metadata that gives end users diagnostics on things like data drift that could be either natural or adversarially input. And then finally, infrastructure is a big play here. Most of the adversarial threats that we have seen, there is an asymmetric investment and use of infrastructure. 1,000 to 1 is a ratio that's not uncommon, where our adversaries are putting 1,000 times the compute and power behind an attack versus 1 unit of compute on the defense side. And so infrastructure, where we run these things at the edge or in the cloud, is also a big part of our defense here.
Thank you. Seek, I think one of the questions is, particularly from your background, is what are the things that you have learned about taking something from the lab and going to scale with it? whether it can go to scale, whether it has the right attributes as it comes out of the lab, what can be done more, what more could be done in preparing a capability that you want to deliver so that it's ready to be moved to scale sooner than what we've done in the past.
Yeah, that's a good question. So one of the things to address some of the previous comments was the idea of the edge, right? We keep saying edge, cloud. It's only binary. But in fact, there's a lot of continuum between them, right? You have the cloud by itself, but then the network infrastructure, the transport and things. So what Brandi talked about, a ground vehicle versus a wearable. Totally different platform, different power, kind of size, material. There's opportunities to put AI in those kind of devices and capability. Something that's running on a ground vehicle would be different from something wearable, for example. So then, from a scaling perspective, is really thinking not just a binary cloud versus edge, but really everywhere along the continuum where you have that opportunity to put it. So the ability for adoption, for example, is not to try to pick the largest model that you have that can run on the cloud, hundreds of megawatts of power, and then with some laws of physics breaking that to say, I'm going to run it in some microwatt, for example, right? But there's opportunities then along that edge continuum to do that. And then back to what Eric is saying with respect to the adversarial and things like that, you got to start fundamental as well, where if you think about adversary, and yes, there's many different ways in which you can attack, and we can't really phantom what would be, especially for edge and edge devices. The number of things that we will deploy with AI capability once it's at scale is so large that we haven't gone there yet. And the nature of that attack is really just unknown. Now, on the other hand, you can think about the basic things that you need. Do you need data model provenance? If you attack, how do you know which model, which one is out compromised, and how do you mitigate that? Basic things like that, we got to start with that fundamental and get there. And the ability to then say, to address any attacks is back to your point, right? The faster we feel this model, the faster we can close the attacks, right? That you got to be in a cycle that you're pushing out new capability, because that's the best way to adapt to any adversary.
Yeah. Sure.
I just wanted to add on, I think what I'm hearing from both of you really is this need for the Army to foster a system that allows us to buy down risk. And particularly what Sek is talking about is that rapid prototyping and experimentation cycle. And particularly for your company, Sek, what you've been involved with Army SBIR encourages that. It really fosters that there has to be, even in a phase 1, a proof of concept prototype. And in a phase 2 or direct to phase 2, you're maturing that prototype to where you're fielding it through that phase 3. And each of those is hitting to what you're hearing up here is that collaboration aspect. We have to be involving our warfighters with those requirements. We have to be involving our firms and our vendors with that rapid prototype cycle so that we can ultimately outpace or outmatch our adversary, but also develop the technology that meets what our Army capabilities need to be.
This is the last set of questions. The last question that I'm going to push on these panelists, and then it'll be over to you, so start getting your head in the game. But I'm going to lead this off before I give this to you so that you don't have to say what I'm going to say. A one-size-fits-all acquisition and requirement system is not going to work. Okay? It doesn't mean they can't be integrated, but one size does not fit all. And so adapting the organization and the incentive structure around that organization and how decisions are made has really got to change. Not necessarily so much for the major defense acquisition programs, but certainly for anything that we're thinking about fixing something in one period of darkness at the extreme. Thoughts on that?
Yes, sir. No, couldn't agree more. And I think what you've seen, at least at the Department of Defense level, at the joint level, is that is why CDAO was created, because there needed to be new organizational structure, especially when it comes to how we move from hardware is still important. The confluence of hardware and software and AI is still very important. But for a data-centric approach to how we're fielding warfighting capabilities, we had to think about the incentive structures correctly, and we had to create a joint organization that was sitting kind of alongside the services to be able to integrate with them. And so that's one of the reasons that CDAO was created. And to your point about new acquisition approaches, that's the whole impetus behind CDAO's recent announcement of the open dagger concept, the idea that we can have what was in the past perhaps government data and government systems that were contractor owned or contractor operated now have the ability for those same contractors to expose all of that government owned data and have new contractors come in and have access to all of that data. So where there may have been a decade of investment by a certain vendor to be able to get all that data, it now enables other vendors to be able to come in who might be very young and allow them to have same access to that data, and also to be able to leverage environments for them from an acquisitions perspective to very rapidly go from they only have an IL2 or just a commercial internet posture. They can quickly go to an IL4, IL5, and IL6 environment within a matter of months, hopefully, and get to the point where they're operating on real SIPR warfighting systems and allowing them to get access to lots of that data they've had in the past. So that's kind of the approach that we are taking at CDAO, and there is, shameless plug, an open dagger solicitation on the street right now for contested logistics and sustainment. So you got about another 10 days to be able to submit your proposals for that.
So netting together the discussion about risk and the discussion about organizational constructs, the other piece is understanding risk. The willingness to risk in garrison in a training environment is fundamentally different than the willingness to risk at the edge in combat. Okay? A 10% solution may be acceptable at the edge in combat, certainly probably would not even get entertained in garrison. And so we have to be tolerant of changing risk structures. It has to be flexible enough to be tolerant to understand that. And if nothing else, it has to at least bias itself towards the higher risk environments than the lower. It seems. And so I kind of turn to you, Brandi. One of the key discussions going on right now is the concept of doctrine. Okay, and how do you think about doctrine in an environment where advantage is maybe 24 hours to 24 days, somewhere in that neighborhood? How do you start to think about it? And it appears to me that the services with activities like CDAO, but also activities like the Futures Command and things like that, are starting to look at doctrine differently. Over to you.
It's a great question. So multiple ways to answer this. So the first, I think, is you're absolutely hitting on it with the collaboration piece. It has to be a joint service approach. You'll see, my background, yes, DAS R&T today, but came from Project Lynchpin, so very familiar with how that is a joint service effort. Project Lynchpin is being informed by what the Navy did, being informed by what the Air Force did. We're utilizing those investments across the DoD to inform that doctrine, which is policy and procedures. How do we deploy and leverage these AI capabilities in a way that's safe and trusted? So the doctrine, 100%. I think you've seen recently, Honorable Bush pushed out a memo about SBOMs, software bill of materials. And then you can see if you're making the natural lineage, you're going to see something come down for AI as well. It should be an AI recipe card or an AI baseball card or whatever you call it, Zach. Recipe card, is that what you call it? Okay. Industry is a preferred term, and we did go out to industry and solicit an RFI for that as well. So these are that doctrine pieces, the governance that needs to go around AI to help us inform our structure. I think the second piece is really what you're hitting at is training. There needs to be a training component. In ASALT's AI implementation plan, you'll see a foundational element of training, not just for our troops, but also for our leaders, to understand what AI is and what it isn't. What are the limitations of AI? The impression that there's this magic fairy dust, I think we've all talked about it up here, this AI dust doesn't exist, or at least Eric tells me it doesn't exist. So there are a lot of problems that shouldn't be solved by AI. And understanding what those limitations are so that we can enable every level of the Army to be well informed about AI's capabilities.
And Eric, I guess to close this out, I'm sure you've seen organizational differences in the commercial sector also. And so can you talk a little bit to how those are starting to emerge?
Sure. Yeah, we obviously as a system integrator, we spend a lot of time at the heart of integrating great emerging technologies with large OEMs, government data sources, and so forth. There's a few trends that we see. First, and I'm top of the list, accreditation is still a big problem. We're seeing way too high a volume still of really great technologies get stuck on accreditation, and it's not just a documentation and authorizing officials. It's not a qualitative exercise. Companies are building software and products that are great, and when we have to get them accredited, it often requires rebuilding completely their underlying capabilities. And for small companies, that just requires costs and resources that they can't afford. So accreditation is still a major blocker in this space. I also think in the venture community, in the startup community, we need to get more creative on how we are providing the department with ways to acquire tech that's not just software licenses alone. You need revenue. You have to get off the ground in your series funding. But if you're looking to sell a license, that's tough. That's a tough ask of a emergent technology in the government to sign off on. So things like managed services, things like professional services that allow you to get skin in the game in an experiment, get feedback from an end user is really critical. And then I think maybe the last point is we got to do a better job together measuring return on investment. We got to prove that these ideas are working. The great thing about AI is there's so much terrific innovation. A side effect of that is that it's real easy to get distracted. And so as a system integrator, we obsess over these, understanding the data pipeline, the data pathway. For ISR missions, for example, it's not uncommon to have more than 3 dozen different technical exchanges, from where a sensor actually collects information to where an operator or warfighter has to make a decision based on that. 3 dozen places that pick up latency, pick up power, pick up noise. And that's a spot that I think we have to together work to get our ROIs away from just model accuracy and put it much more on, are we improving the speed of decision? Are we able to have a higher throughput in decisions? So there's just some blind spots, I think, when we go to measure results that we're still working to improve.
Awesome. And over to you all. Right in the center.
If you will, just wait until you get the microphone so that others in the back can hear you.
Hey, good afternoon. Joe Mauser from ADI. I have a 2-part question. General, you made a point of making the distinction between the larger experimentation that's part of GIDE and the limited experimentation opportunities. I'm wondering if you could give me a little bit more insight on how to tap into those limited experimentation opportunities, and as part of those, are you evaluating both the capabilities as well as the tool sets that develop those capabilities? And if the answer is yes, back to that accreditation thing, does accreditation kind of stand in the way of something like a limited experiment, which is kind of a first peek to say, hey, is there a there? So that's my question.
I guess the first piece on the limited objective experiments, there are best I know, there's about a half a dozen of them. Almost all of them have some heritage and sponsorship on the Guard and Reserve side to host in an area at a reasonable price, number one. They're almost all located near a major facility, DoD facility. The one that I was referring to is up in northeastern New York, right next to Fort, some big Army base, and Air Force, et cetera. And so you pull in the pieces that way, and they have figured out how to get large areas of land that give you every climb in place, so to speak, any kind of global landscape you need. They have tools like adversary systems, trucks, vehicles, sensor systems, et cetera, that you can work against, and all sorts of capabilities out there that are instrumented in a way that allow you to do this we're trying to keep it at an extremely reasonable price so that a small business can come. And so in the transition to the second piece of your question, when they bring their systems out, almost always we furnish the power off of a government-operated platform that would be there if their system was fielded. And say, you've got to be able to operate off of this Humvee's generator, or you pick it. And so that's set up kind of at the front end, both to give them mobility and demonstrate ruggedness, but also to demonstrate the need for the power consumption side.
I can just add to that on the accreditation piece. Most of our LOEs are sponsored with the research labs, so it's relatively low technology readiness level. I'm trying to think, 1 out of 12 that we've done had an accreditation requirement. We do, though, look forward in terms of what the future hurdles may be in thinking through what we're delivering. We do a STIG compliance check, document things, make sure that we have a light POEM in place that gives our customers an understanding of the trade-off. Tech is great, but this is going to be a nightmare to rebuild, or 18 months to recode in compliance with those STIGs and security controls.
Fort Drum, that was the one. Next one, next
Right
question.
here.
Leslie Steele, Pixel Rain. Brandi, you made a reference to AI governance. Can you elaborate on what specifically you're referring to?
Yeah, absolutely. So you'll see some information come out a little bit later this summer on ASALT's AI implementation plan, and that will include what they intend to do in the next 500 days. And part of that is AI governance. You also heard Eric talk a little bit in the beginning about TORC, T-O-R-C. Those were key concepts laid out initially by Project Lynchpin to inform how should the government approach AI. And you'll see more of that. We are looking at each stage to industry to help us understand, is this the right approach? Because we fully recognize on the government side, we're not the experts in AI. You all are. And so that's why we issue these multiple RFIs, multiple opportunities for industry to give us feedback on what we are proposing as our concepts for governance of AI, for TORC, for these scalability concepts as well.
And so if you look at in the construct of policy, norms, regimes, and law, okay, disruptive technology destroys norms and regimes. What's common practice, et cetera. And so this effort is to start to rebuild and reconnect policy with law so that we can actually operate in this area in a coherent way that we get an expected outcome, or when know when something's anomalous. I think that's really, really important and underappreciated often. Next question.
Hi, Kimberly Ellenberg, pleasure. Question that I have for you is, so I know we're getting ready for the big one, right? Like Sanford and Son would say, right? But reality today is protracted wars, right, through attrition. And so we have a lot of low-flying objects, and this was published in the newspaper, so this is not inappropriate to say, that are using gas that can be deployed to flush people out of trenches, just like old-time trench warfare, and then they're fired upon by another drone, right, or unmanned ground vehicle. So the question is, do we need to be thinking about any of that, given that's a reality? So kind of parallel to thinking about the big one. And if so, one of the things I'm wondering about is the changes that we would need to think about from a systems engineering perspective because of some of the quantum computing that might then be needed for a swarm of self-healing drones at the edge that would counter those low-flying objects. So I think that was kind of a question to you, Nomad, and to you, sir, the system engineer.
Yeah, I'll let Matt start.
No, thanks a lot, Dr. Ellenberg. So this may be also one good for the Army to answer in their mission sets, but what we at CDAO are trying to do is, one, not focus exclusively only on one mission set, like the big one, for example, but also realizing that if that does happen, there is going to be elements of warfighting missions that really overlap many of the things that you talked about. And so we are investing in not only abilities for us to be able to do cloud well, to be able to do warfighting functions well and data integrations well at the cloud, but also to be able to invest pretty robustly in emerging capabilities like global data mesh services, which we're looking at to try to help the resiliency of the way that we do things. So it's not just cloud direct line to edge node, but it's cloud to a resilient data mesh that can connect into service data meshes that they're working on, so that we at a joint level can have persistent connectivity and resilient connectivity, and then can enable really a heterogeneous mix of mission sets, because it may be a robust counter UAS swarm capability that we have to counter, and we may not be able to foresee that right now, but we want to ensure that we're fielding capabilities that can very quickly adapt to whatever we would need. So I hope that answers your question.
I think that was spot on. I think, back to our brief conversation around architecture to solve a variety of problems, again, applications, data models, pipelines, platform, infrastructure. Some of the capabilities Colonel Noman just mentioned, like data measures, are combinations of software-defined networks with infrastructure at the right places that are going to allow for visibility into threat data as you're describing. They also allow for the integration of emerging tech like quantum in some cases. We've seen quantum use cases really focused on optimization, positioning countermeasures in places that are hard to determine through traditional mathematics alone. And so I think for scenarios that are complicated like that, that could be an applicable use case.
Next question.
Hi, Eric Hsu, work for the Secretary of the Air Force Studies and Analysis. Questions for Colonel Strohmeyer. Obviously, it's fair to say that GIDE's probably been pretty successful at proving the technology is available for automating C2. So kind of when do we move away from experimentation and actually to implementation?
Great question, Captain Hsu. Thank you. So I think we've taken we've been doing GIDE at the OSD level now for about 18 months under the direction of the Deputy Secretary of Defense. We've had 7 GIDEs that we've run, and I think we've taken some of our cues from industry and how we used to have these big flash-in-the-pan GIDE events, which were very successful at learning quickly on a 90-day cadence, but what we found is that wasn't fast enough. And as we matured the technologies, to get to your point about, okay, some of these are ready to move into the field, we found that we had to have a persistent system of experimentation. So we've gone from, yes, we have major GIDE events every 90 days now, but we have now weekly and bi-monthly mini GIDE X's and GIDE technical workshops, which very much kind of, I think, are following on what we've learned from our industry partners, that we have to get more reps and sets to be able to more iteratively deliver capability. But we also are pushing things out into the field right now. So several of the things that were fielded in our min-viable capability for JADC2 last year are in operations today at multiple combatant commands across the globe. And we're looking to expand on that fielding of those capabilities and operationalize them in GIDE 12 coming up here in about 45 days or so. It was an excellent question.
Yeah, the only thing I would add to that is I would kind of push the concept of how we're defining transition, because transition doesn't mean or equal integration, and I think we have conditioned ourselves to think that. It's only a success if it integrates, but particularly in the AI space, we have in the DoD a wheel of 10 transition points, and any one of those is considered a success. So even if an effort such as that informs our mission, we're going to say that's a transition, and that's a success for us too.
Yeah. I'd like to add one more, which is from the startup perspective, companies working, right? We have great technology, but we really need to understand what are the requirements. So once we're embedded into an experiment like that, we have an understanding of, oh, this is exactly what you want, and the transition possibility then becomes greatly higher because you have now added it in. One of the biggest things would be security, right? That you can't just willy-nilly data into it. You got to think about your impact levels and things, and just basic things like that helps in terms of that transition.
I think I'll take my prerogative here. I guess we're going to close it out here because we're supposed to stop. You really want to get in there?
I really do.
Okay.
And I'm going to do this on purpose because I haven't seen General Cartwright for 13 years. And one thing that didn't come out in his bio is the amount of times he spent in the White House for all the deputy committee meetings. We were in there together. And I just wanted to say that no matter what the topic was, Iraq, Afghanistan, H1N1, burn pits, vet suicide, bin Laden takedown, Haiti, you were always prepared, sparring with Tom Donilon. I'm probably giving you hives hearing these names again. Hillary Clinton, you were always prepared, and I just want to thank you for being a fierce defender of those of us in uniform because you stood up and made things happen.
Thank you. Appreciate it.
And my question was really based around DoD Directive 3000-09. How do we make that functional? Because I think at the edge means there's capability where sensors, sense-making and acting is going to be far more informed than anything happening in the rear. So how do we make that directive functional, that we can experiment, that we can learn from it without being, politically restricted by, what that means? Thank you.
I think I'm not going to answer because we haven't got enough time, but I'll catch afterwards, or any of us can do that. My sense here going forward, just big stroke. One, we're doing a lot of exercising and prototyping, which is really valuable in fast turn type activities, but it's still not anywhere near the scale that we need to operate. Combatant commanders get things that are experiments or prototypes, and they don't know what to do with them. I mean, and you get 2 people, 10 people that really like the idea, but that's not enough to sustain it once they get orders. Okay, so we've got to start to think about a different front end to this activity, one that is not just limited to experiments. It gets its birth in experiments, but it gets wide distribution in shadow modes and other kinds of digital activities that allow us analytically to understand better, to get closer to a 90% or a 50% or whatever solution than what we can do today with the constructs. And so there's an awful lot of work going on in this area, and that's also leading us to the realization that most of our control centers in all of the services that run the tempo of the fight are limited to scheduling, sequencing, deconflicting, not parallelized activities swarm. And this is going to bring those types of capabilities, which are fundamentally different ways of doing business, both at a headquarters, but also at the very edge. And that's just in front of us. I mean, automation, power management, and parallelized activities are all where we are focused right now. We're just at the beginnings of that. And I think that's where we will end up being. And, an experimentation program and some sort of a prototype is okay in the first level, but I got to get to 2 million people looking at it real quick. And right now the system is not designed for that, number one, nor is it designed to command in a parallelized activity where all of the pieces are being put together and run at a speed that human cognition is good for command guidance, but is probably not fast enough for execution. And that's a really painful thing for us to deal with. Thank you so much. Appreciate it to the organization. Appreciate it to all of you for being here today. Thank you.